Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds the largest value in each level of a binary tree. First, let us take an example. The idea is to recursively traverse tree in a pre-order fashion. Root is considered to be at 0th level. While traversing, keep track of the level of the element and if its current level is not equal to the number of elements present in the list, update the maximum element at that level in the list. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We take a vector res and pass the vector root 4 and 0 to helper function. Since root is not null, the second if condition is satisfied, we push the root, which is 4, into the vector res. Next, we pass the left child of 4 along with d plus 1. Again, as d is equal to res dot size, we push 9 into the res vector. Then we pass the left child of 9, which is 3. As root is not null, but d is equal to res.size, we push 3 into the vector. We pass the left child of 3, which is null. As root points to null, we return to the previous call. Next, we pass the right child of 3, which is also null. Again, as root points to null, we return to the previous call. Execution for node 3 is over and we resume execution for node 9. Now we pass the right child of 9, which is 5. As d is not equal to res.size, we go to the else part and store the max of res2 and root. Since element at index 2 is 3 and root is 5, we store 5 in place of 3 in the res vector. The left and right of 5 are null, so we return and finish execution for node 5. Execution for node 9 is also over. Now we pass the right child of 4, which is 2, so root points to 2. As root is not null and d is not equal to res.size, we go to the else part and store the max of 9 and 2 in res2. Since 9 is greater than 2, nothing is changed. Then we call for the left and right children of node 2, which are both null. As they are null, we return and we have the final answer stored in res vector. With this, we finish execution for this program. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.